Okay, I just want to tell you that we're going to do participation credit again Friday. I'm joking. I just recorded it. So when they watch this tape, they will panic for about 2 seconds. Okay, I hope that's not too inconvenient. All right, so right, today we're going to continue with the overloading. We're going through overloading and then going through, essentially today we will finish the whole chapter 12. There are two topics, overloading and constructor. I want to learn two things. Number one, there are good stuff in chapter 12 that you need to learn how to use constructor, how to use operator loading properly. But also, I also want you to learn, in fact, both this content, both the constructor destructor and the overloading, I feel that there are certain things you should never use. It's confusing, it's actually causing problem. So let me actually first tell you that this is the example I start to show you this overloading greater than. So the semantic of the meaning when I say I have operator overloading on comparing two person. And immediately is either between uncertain and even to a risky situation is that when you want to use this piece of code, you don't really know what's in there, what's compared. If I don't know you're using algorithm A versus algorithm B, I probably don't care. That's your intellectual property. But something has to do with the semantic meaning of the result itself. For example, comparing two person, as I mentioned, am I comparing this two person based on their, say, I just pick a few things, their blood pressure or their sports skill or whatever, their muscle strengths. And the thing is that you could be comparing a lot of stuff. And exactly which one, when you call this piece of function, that you really need to look at the code, inside the code to decide. For example, you really have to look at the implementation of that function and to decide. Okay, so that is actually, I call it, we actually break the principle. We call it encapsulation. If you remember object-oriented programming, I hope you have the picture in your mind that what we want to do is we want to put a few things, the code, the implementation detail, as well as the data structure about a person, like a person object. And the thing is that we provide some designated interface. And when you actually try to access the object, you have to use those given specific interface. Well, however, when we release the software, that this concept is actually very important in object-oriented. I think encapsulation, in some sense, should be put in a higher priority than any other object-oriented paradigm or principle. Is that I don't have to reveal no more than I should in order for people to use this object. I want to release as simple as possible. I mean, think about, I have a computer. Apple does not show you anything inside the electronic circuit or whatever the chipset they use, or maybe even inside their intellectual property design for a particular component in this computer. All they give us is this bare-bone machine with some software called operating system that designed to let us use it. Well, unfortunately, when we use operator overloading, unless you use carefully, which means that the semantic meaning is so clear, then you should really, really be careful when you use it. I mean, I showed you this photo last time, this picture to show you the separate compilation. And the purpose of separate compilation, you see that I always separate the .h file with .cpp file. Because when I'm going to release it to public about my software system, I will release the .h file only. .h file only provide the interface. And then I actually will compile all my .cpp file and link into a library, and such that you will only see the compiled version of that. You can actually link it to actually be able to run your program. But the thing is that you don't have the source code. In this case, if you do operator overloading, then what I need to do is that at least some of the operator overloading you want to use, you need to include it in .h file, because otherwise people really don't know what's the detail. Okay, so that is something which I want to know. There is a good thing, but we have to use it carefully. Okay, so if you have your computer, regardless is Linux or Mac OS, in fact, you can actually look at the template for doing. We will talk about template much later in the quarter, but there is a template to implement operator overloading. In my computer, which is a Mac, I have to do it this way because the bar from Zoom actually block it. It's actually under here /library developer, and then all the way. The last one is called utility. So utility is a file that's actually defining all the operator overloading, particularly in what we call relational operator. So relational operator has 6: equal than, equal, not equal, smaller, bigger than, and greater than equal, and smaller than equal, and those 6 operator. But one thing is interesting. I want to actually show you this. This is just a compiler trick. You should know this because this is actually quite popular, especially other people will use this way. Okay, so I'm going to show you directly this one.
So anytime we have to overload, we have to use the smaller than even for greater than, right?
Yes.
Because that's the standard way to work. Like when you create a library or you overwrite anything that is you're overriding the default behavior,
right?
You have to use less than for any conversion, right?
So there are two issues. First, we should actually know whether you want to overload the whole set of 6 relational operator, or you just want to overload specific one. The difference is that you actually need to use, if you include, remember the file I showed you about utility. So there are 2 things you need to do if I want to use the template. First, I have to include the utility. The second one, I have to say I'm using namespace std : relational OPS, rel_OPS. If you actually including those 2 lines, then what you need to do, as I said, there are 6 overloadable relational operator. You only need to specify 2 of them. And the thing is that you can think about, I have 2 pieces of code here. One piece of code is basically have a 2 overloading operator. One is equal, one is a smaller than, and the other one is equal, and the greater than. This is a bit artificial. This one is actually good, and this one is not. This one actually will not be able to do that template. So the rationale is the following. The rationale is this. If I have defined 2 of them, which is equal, and smaller than, if I only define this 2, then the compiler, because I include the rel_OPS as a named scope, and I actually know that I'm going to do the trick. Because I have an equal, then it's very easy for me to implement not equal. That's actually essentially what this code I show you was doing. Sorry, let me just flip back. If you see this is doing, this is a template. What is operator not equal is basically return not operator equal. Okay, so it's essentially using the one you define. You only need to define 2. One is equal, one is smaller than that. And then it will basically handle the rest. So for example, greater than, smaller than, I actually have a smaller than already. If you want to implement greater than, I just flip this to parameter. Then I have a greater than. So essentially, that's why you look at other people's code. If they want to use REL OPS, they always declare only two. One is equal, one is smaller than. And you use the smaller than, equal, and the not. And then you can actually implement anything you want. That's why the compiler is just helping you to use those templates to do that. Okay, so just let you know, this piece of code is okay. Which one? Oh, I will publish this slide. Yeah, I'll upload this slide. So this one is not okay because it's actually inconsistent, because this one doesn't have operator smaller than. So you see that the template utility I just showed you, it actually doesn't have that. Their implementation greater than is actually different than what you expect. All right. All right, so that's actually another trick I want to tell you. The final trick I want to show you, there is another way of representing this. So I'm going to show you this two option, and you can actually write exactly the same kind of code. So the top of the code is what we have is if box 1 is greater than box 2. And you in fact have two different way of representing the greater than. You can either do operator overloading inside the class, have a class box to have operator greater than, like what we described earlier. Or you can actually do what we call inline operator overloading. So you can actually declare this way. So this is not under any class. It's just operator that you can overload. And the thing is that the code, whatever doing the comparison, is going to use that. Because it's inline, typically it actually will be included in a .h file. So typically this might be a nicer way because usually the source code is available. Whenever people use inline, the code usually tend to be very short. And the result is similar. So you can potentially use this kind of global operator function to do that as well.
If the code or the function is, say, 15 lines, the compiler would not consider it online, right? Even if you write inline during compilation, the compiler would just treat it as a regular function.
You can still get it to work. I mean, the thing is that in C program, I don't really have a line. I can actually have a really long line. I can actually put semicolon, backslash, it will still consider as a one line. I don't think compiler will actually complain if you write multiple. It's not really line. You just put a long line and then with maybe backslash to kind of continuation. Because I have seen inline for half page of code. I have seen that. People just, it's kind of convenient. I mean, the reason people do inline sometimes is for compiler optimization. It's much faster. The compiler optimization, at one time, they thought inline is a good option, but there's the compiler optimization, I believe, I'm not an expert that, but they actually developing a way they can do all kinds of tricks. So I think having inline or no inline is not going to be a huge difference. Yeah. All right. So hopefully that gives you some idea about what is the operator overloading. If you use the wrong, you're actually going to see this kind of arrow. That's actually because you define it differently. Okay, so now I think that is my conclusion about operator overloading. So I just want to emphasize, number one, operator overloading is really for readability if it's appropriate. And the second thing is that you really need to know that if you want to do operator overloading, make sure the semantics of that operator, when you're comparing two objects, they're actually make sense, or the semantic is clean. Otherwise, you will make your code very unreadable because people will interpret that operator overloading. For example, when I say person A is greater than person B, I thought it should be for blood pressure, but it's actually is for something else. Okay. All right, so now I'm actually going to talk about the second topic today is constructor destructor. So there are in C++, there are three type of constructor. The first one is called default constructor. The second one is called copy constructor, which is the most commonly used constructor. And the third kind of constructor, by the way, all of them are kind of could be implicit defined, means that if you don't have this, the compiler already actually included. That's why it's called implicit constructor. So there's a default one, and then there was something called copy constructor. There's something called move constructor. So we have to see semantically how to specify what kind of constructor you're using. So let me actually use this slide to show you this three constructor, the format. So this class data, I define a class data, which has some value. And I have a three constructor. The first one is purple, take no parameter. That's called default constructor. And the green one is called copy constructor. So copy constructor, essentially you say, okay, I want to create an object, but I want to take whatever the content from the other object, I want to copy that. So that's why I said this is the most commonly used constructor, because usually, typically, when we actually construct an object, we like to kind of inherit, or not, I shouldn't use the word inherit, because in C++, inheritance means something else. And so essentially, you want to just make sure you have exactly the same copy, you use copy constructor. So the semantic of copy constructor is the green part. Let's look at the green part. Is you have to specify, the first one is const. Const means that I actually allow you to copy, but don't modify anything. That's why we always say it's a const. And then when you do copy constructor, you specify the type. And the type is always data, whatever the object, and then with one n sign. That means is a reference. Meaning that, okay, now I'm going to refer to that object. I'm going to copy all the value from that constructor to the current object. So the green is called copy constructor. I mean, for most of your purpose, you probably just need to use the top two constructor will be fine. And the third constructor, I will strongly argue against it. And the reason I need to teach it, because I want you to at least understand what it is, so you can actually understand the code. The concept is called move constructor. So move constructor is essentially, you want to take the value from the previous object, but you take it out and you put into the new object, but then the original object, that value is gone. So that's why the move is not copy. So essentially, you can think about move constructor is like a copy constructor, but it makes sure after you've done it, there's only one copy about that particular content in the whole world. That's the only typical, that's the only way that you can interpret or apply copy constructor, is that you want to only keep one copy of that content. After you do the copy, the other one is gone. Well, the reason I said this is unnecessary, if I want to have a way to maintain one copy of something, then I probably have other ways to do it. But the other way I really want to argue, okay, the other way I really want to argue is that in the real world application, I haven't seen any application that's actually required something can only have one copy. Think about that. Can you think about one application? I'm talking about computer application or programming application that you actually is undesirable for you to have only just one copy.
Yeah. The new code.
The new code. I want to back up, right? I need to do a backup. I need to do backup. I need to do GitHub. See,
You're not talking about the nuclear code the president has to carry.
Well,
You can
well,
only have one copy of.
okay, let's see. Okay. But, okay, there gotta be another place. Usually have a 3 copy or something, okay? It's hard to have, you have a 1 copy, and especially in computer, because we need to do backup. So that's why I think if you really want 1 copy, you have other way to do it. You don't need to design a language to make sure that 150 ecs36b student suffer a lot to actually understand this content. I will show you my code to tell you that why I really don't like it. Okay, so the way to specify is actually interesting. You have to say data, the object name. You have to put 2 n sign. You have to put 2 n sign. I mean, it's 1 reference is already give me enough headache. I need to put 2. And that 2 doesn't actually justify the complication. So let me actually show you a piece of code. So I want to show you this piece of code. So we have a 3 constructor. Let's actually first, yeah, okay, let's look at the code. This is the code. I actually have all 3 of them. Take a look at the code, and I will need your help. First, I actually modified the code a little bit. You know what? If you want, I realized I forgot to put it into the GitHub. I should. I'll put it in the GitHub after this class. So I declare this data. Now I actually talk about this data is an integer pointer called int star, means that it's an integer pointer called value PTR. And the first one is default constructor. The default constructor essentially just saying that I create a value. Oh, now I actually should tell you that the other thing, which is about new. You never heard about new, probably. So the default constructor is usually just say, hey, I want to create this object called box or person. It will automatically invoke. But there's another way you can actually create an object. It's called new. So you can say new, whatever the class name, and with whatever constructor you want to put in the argument. So depending on what the data type of the argument you put in that ... it will invoke one of the constructor. Default, copy, move constructor, or other. By the way, you can have other constructor, you can actually specify. Okay, that's your choice, but this is our implicitly defined. So what new does is actually return the pointer to the first byte of the object. Okay, so now we talk about pointers, so now I start touching this concept. So a pointer in C is really a memory address. If it's a 64-bit machine, is a 64-bit number. And when you create an object, I must find somewhere in your memory enough bytes so I can actually store your object. So you think of an object, if you go down to the deep memory, it's really just 0 and 1 occupied somewhere. And that somewhere has a memory address. And that memory address is called a pointer. So essentially, if I want to access to that object, I will just go to that memory bank with that memory address, and then I can retrieve that value. That's why there is another way for you to do that is actually using the new. So let me actually just go back to think about this. If I have this called value pointer, a new int. So essentially I create a integer, which is typically 4 byte or 8 byte in my memory, and then this will return me value pointer to be the address of that. Okay, that is my first introduction to you about pointer. So I have 3 attribute. One is data. Inside I just do new, but then if I do copy constructor, look at what I did. Inside the copy constructor, what I did is I just copy the value of the object I'm going to copy and put the value into that local value, and that's copy. Yeah.
So does new like allocate memory, or is it just pointer?
New actually allocate memory. New, if you are familiar with the concept malloc, new is essentially object-oriented malloc. Yeah. Okay.
And it's good practice every time you use new in your class to be defined pointer, then it's a good practice that you have a default destructor. Like
Yes,
every time
yes.
the minute you create a
Right.
pointer or new, write a destructor right away.
Right. Okay. So there are two things I do want to mention. If you use a new to construct an object, and that object doesn't include any pointer, like in this case, it's not. See, this is a class data. Inside the class data, I have a pointer, right? So I'm actually have a pointer as an attribute inside the object. If I don't have that, then when I delete it, it will delete. I have no issue. However, if I actually have this pointer, then what I mentioned to you can see here, I actually comment out, but I actually should have this, right? I should say delete value pointer. And I think that sometimes this could be dangerous because if you don't do it correctly, and sometimes you mess up your memory. That's why I highlight new and the delete, they always has to match. Okay, so then I'm actually going to do this. This is called move constructor. Essentially what you're doing is I actually move the value from one place to the other. So this place will have the new value. Okay, so now I'm going to show you the code that's actually going to be really interesting. Let me actually show you. Am I going too fast? Wait a minute. Why I'm ahead of myself? Hold on 1 second. Okay. So I want to just go through this piece of code. Spend some time. Take a look at this code. Okay, spend about maybe 1 minute to make sure you understand the code. Okay, now I'm going to show you this piece of code. So I have three different constructor. I want you to actually focus on this part, this few line over here. And there are 6 cout statement, means that it's going to print out the value of A dot value, B dot value, and C dot value. There are 6 statements. I want you to actually write down. Why don't we do this? You talk to your neighbor to decide what should be the output of the 6 statement. What should be the output of this one? This should be relatively simple. And what should be the value of this 2? And what should be the value of this 3? Okay, think about this. I give you 1 minute to take a look. Okay, let's actually go over this. What do you think it should be the output of this one? 111. Okay, that's great. What should be the value of this one? Yes, it's 111 because this is what? This is copy constructor. It's a copy constructor because see one M sign, that's copy constructor, right? Look at, be careful about the type. So, okay, there is a concept I never cover. Some of the instructor also didn't emphasize enough. This is what we call casting. Casting means that you actually convert the data type to a different type. So what is A? A is a data string object, but you casting A to a data string ensign. You casting that to a reference type of data. So in C++, in terms of memory, they're the same, but in terms of type, they're different. And you see that I actually casting this case, I casting to two ensign. That means because I casting, it became a different type, and then it actually changed the matching function signature. That's why this is the way I can actually trick my code to actually call copy or move constructor instead of everything else. Okay. By the way, later you will realize that casting. By the way, I should ask for Java programmer. I know Python programmer never need to do casting. Does Java programmer need to do this kind of casting? Never heard about that? Oh, you also need to do casting?
But there's no pointer, so you don't do it as often.
Okay, thank you. I'm just unfamiliar with Java situation. But you see, C++, casting is so commonly used, and not only so commonly used, it's a fairly tricky. Sometimes the casting it changed the memory address unintentionally. It's fairly complicated when we look at the inheritance, especially when you do casting with inheritance. Your pointer value is actually going to be messed up. Yeah.
Could you briefly explain what exactly casting is?
So casting is that I put a data type in front of the object of the same type of different type. So if I don't have this casting, when I look at the A, is whatever the original type it was declared. But when I actually do the casting, I look at the whole thing, the A is no longer the type that it has. So let's not worry about object-oriented. For example, I have something which is an integer. I can actually casting as a floating point. So essentially become 1 to 1.0. So that's what it does. It basically is a way to convey the information to the compiler about how I as a programmer want the compiler to treat my data in that sense. So essentially you can think about it's a type conversion in terms of casting. Okay. So I'm doing a casting. So that's why this one is a copy constructor. And this one, because the copy constructor A's value is not changed when you do B. So this one should be what? Should be 111. So you're all right. And this one, 222, right? That's because I already modified B's value to be 222. So this one is going to be 222. Okay. So let's actually look at this part first. Okay. What about the last line? What should be the output of C? 111, right? Because it's actually a move constructor, the value. And how about B here? Still 222, right? It's not changed, right? Because I'm not touching B, and B should be exactly the same way. It's copied. So
A doesn't exist now, right?
A, what should be the A if I do this?
Does it, okay, so does a move constructor destroys the object or just nullifies the object?
That is actually value implementation. That's the tricky part. Is undefined. The term, technical term, if you look at that, is undefined. So in this case, in my compiler, the result looks like this. So I can still use it. I can still call it, but then it's actually undefined. It's gone. So essentially move constructor is doing is that they let C take the memory content of that particular originally which holds by A. So essentially it's a memory content, so you can actually do that. It's very interesting. Some of the people argue that it's for performance. You can actually do a less memory copy, for example. You can just use that. But the thing is that people actually tested with move constructor against Java and realized that move constructor is even slower in that case. So let me actually just show you the code so we can actually play around a little bit. I will send you the code. Let me see. Where is my code? Ah, here. That's the code I'm talking about. Is you actually get the empty. But let's look at the code itself. Data. Let's see. I have a lots of code here, so I want to play around. Emacs minus. Okay. Oh, this, by the way, is a string. So basically, that one's nullified to be a null string. That's why the code looks like this. All right. So that's the code. And I just wonder, offer to you, anybody want me to modify something and see if the result is going to be different? Anything you would like to try with this kind of constructor?
Is it indented before? All the cout statements? No.
I don't know. Maybe it's a different screenshot I'm taking. And so let's actually do this. After I do this, I do a copy constructor. For example, let's try to guess what this is going to happen. Okay, if I do a D, I do a copy constructor. What do you think it will be the value?
Yeah, it's undefined.
It should be undefined. I just print a C to make sure that the value is nothing changed. Let me actually do an A. Yeah, a lot of undefined, right? It's because it has been nullified. Okay, so you have a question or? Yes, please.
Oh, yeah, I just had a question. So when you call the constructor, like when you create the B and C data strings, why do you not need to use the new keyword?
I could do that as well. Let me actually try to do this. Let me do the data, str, star. Okay, new, I need to do a pointer. So this is EPTR is equal to new. This is going to be data. And inside here, I'm going to do the same thing. I'm going to do data, string, and I'm casting because I want to actually create a copy constructor. Okay, let's see if this will work. After I do this, I will say EPTR to the value. Yeah, that's the right syntax. I can do it either this way, just let you know, for those of you unfamiliar with a pointer, or I can do star EPTR dot value. Those two are exactly the same thing. Did I make a mistake? I missed something because it's actually not.
I think after new data, it should be data string or data str.
Oh yeah, that's why. That's why. Okay, is this good? Something is not right because is okay. Let's compile, and the compiler will give me the what I did wrong. Yeah, I have a one extra. That's why I put a one extra right parenthesis. That's why I. Yeah. Okay. So now this one. Yeah, that's why Because if I have a syntax error, my tab key won't work correctly. That's why. Okay, so that's the way to invoke. So you can also use new to invoke different parameters. Okay, I'll show you this. I will actually upload to the GitHub so you can play around yourself. Learning this type of thing is really good for you to try out this kind of small program. All right, so let me wrap up with what we have. So we talk about the constructor, and also I'm going to combine the concept of operator overloading with the kind of copy from constructor and move constructor. I can also have operator overloading as an assignment. I can also do it in a copy way or do a move way. This is a move assignment, this is copy assignment. The similar semantics and the similar way of invoking the function. So you know what is that. So this is actually a useful thing for you to actually understand. So I just want to tell you there is two things you want to learn from the constructor. Again, you want to make sure those are implicitly declared. So you want to make sure that if you didn't declare your own constructor, you want to make sure that, for example, even the equal assignment, it might be implicitly declared, and it might actually cause some kind of unexpected problem. For example, you're actually casting the wrong thing. If you're casting the wrong thing, you might have that trouble. And the other thing, which we mentioned, the destructor is really worried about the memory leak. So whenever you use new, you want to actually have a way to say delete. So let me, technically, I should actually go back to my code. I should go back to this code to tell you that the way I need to do here is set at the end, I should say delete EPTR. This will help me to delete this one. Okay. Let's make sure. Compile, good. Okay. All right. So we're essentially done with chapter 12. I cover only the relational operator, constructor, destructor, and there are other type of operator you can actually overloading as well. For example, you can overload plus, minus, those kind of unusual. What do you mean by plus a box with a ball, for example, two different objects? What do you mean by plus one person with the other person? And also there's a subscript operator. Subscript operator, you already start seeing it in the JSON. JSON is actually the CPP library actually overload that. But it's the same principle that you need to do. It's really for readability, and you have to be very, very careful about not using it. Okay. All right. So there are some detail about the constructor, about the constructor, about the overloading. There are some pointer I provide in the slide, which will in fact give a lot of more detail. I don't think it's actually very useful for you to learn all of that, but as a programmer, you just need to know they exist. And when you actually have a situation you feel is appropriate to use this, at that time, you can actually go there to check. And as I mentioned to you, the best way to learn is actually write a small program and try to test out, because manipulate some program with minor changes, that's actually going to help you a lot to learn the subject. Okay, that concludes my chapter 12. So now we're going to move into this two chapters together, starting Monday, is inheritance and polymorphism. I'm going to do both together. So if you like to read the textbook, you can start read both chapters. Okay, so you all have a good weekend. Is our TA here? Rajesh, are you here? Give me one second. 1 second, let me